calling Olympia High School. We are currently closed. Our normal operating hours are Monday through Friday from 7 a.m. until 4:30 p.m. If you know your party's extension, you may enter it at this time or their mailbox. We are currently closed. Our normal operating hours are Monday through Friday from 7 a.m. until 4:30 p.m. If you know your party's extension, you may enter it at this time or their mailbox. We are currently closed. Our normal operating hours are Monday through Friday from 7 a.m. until 4:30 p.m. If you know your party's extension, you may enter it at this time or their mailbox.
Hello. Okay, so I know I'm not there first period. I had doctor's appointment, so I'll just do a live stream here. So those of you guys can hear me. There was, if you're in first period, there was a unit circle on the left side of the room. If you face to the front, there was a unit circle pile. Just grab one sheet of unit circle. That's all you need for today. So there was a unit circle on the left side of the thing. Okay, Gabby, can you hear me? Gabiola? Gabby, can you hear me?
Yes.
Okay, so can you let the classroom know on the left side of the classroom has a unit circle? Each person's going to pick up a sheet from there. Don't worry about the other pile because we'll talk about when we come back. And we're going to go through live stream how to go through a unit circle the correct way. So. So what we're gonna do is make sure that we go into a unit circle correctly. So tomorrow you will have the quiz tomorrow. So you can watch this video several times if you want. So we're gonna start with the unit circle. So we're gonna pull out unit circle. Templates. Okay. So we're gonna import it to the notabilities, create new notes, import. Okay. So here's a unit circle, and a lot of you guys need to understand unit circle. On the back sheet of unit circle, it has a formula sheet. We're going to talk about a formula sheet, and we're going to talk about unit circles. So let's start with the unit circles first. And let's talk about, there was a Sohcahtoa. And each thing you have to understand clearly. So first of all, I want to address something that is a little bit different from other people. Is I will tell you that there is a line here. And it's going to form some type of triangles. So Let me see if I can do it. Okay, there is. So those are one type of triangles right here. But this triangle is split into two. And we're going to talk about this triangle. I'm going to shade a different color so that way you can see it. And we're going to have a different color of here. Okay, so there are different type of triangle here. So first there was this type of triangle right here. And second, there was this type of triangle right here. And third, there was a different type of triangle right here. Okay, so those are the things that students need to see. The height and the base of a triangle is very, very important. And we're going to talk about that. How is that related to SAT? So let's start with the angles first. So I will tell students to deal with angles first. So the angle is really easy to determine. So this is a 0 degrees. And this is the whole circle is 360 degrees. Half of a circle is going to be 180. Half a circle is going to be 180. Now here is going to give you 90. Now here is going to give you 270. Now half of 90, that's going to be very easy as well. Half of 90 is going to be 45. Just basically divided 90 by 45. And here, this angle here is basically 45 degree added to 90. So it'd be 135. And also 45 added to 180, so it's 225. And then that's going to be 315. So now what happened is you have a 30 degrees here. And you have a 60 degree here. Always remember that. So kind of know that this is 90 degrees, right? You break up to 3 sections, and this is the sections. Each one's going to be 30 degrees. It's like kind of like a fan, and you break up to 3 individual pieces. They are equivalent pieces. If it's a 90 degree, you break up to 3 pieces. You got 30, 60, 90. So each of those small things. Now, in terms of actual, if you look at this as a clock, there's about 1 hour difference between 2 o'clock and 3 o'clock. This is about 30 degrees. So it'll be 30, 60, 90. And next thing is going to be 120, 150, 210, 240, 310, and 330. So we finish all the angles. Now let's work with radians. And radian is easier to work with. Actually, radian is harder to deal with. So first of all, you have to understand some basic information. A circle is 360 degrees. 360 degrees is equal to 2 pi. That also means 1 pi is equal to 90 degrees. No, so 1 pi equal to 180 degrees, sorry. 180 degrees. And a half pi is equal to 90 degrees. So if you know in that 0 here and 2 pi here, that's going to take the whole circle to complete that. And now here it's going to give you a pi because that's 180 degrees. So that's equivalent to pi. 90 degrees is going to be half of pi. And that makes this one's pi over 2. Now, I will tell students there's a small tricks that going to help you a lot. The pi in this region here, that there is a pi here. Sorry, there was a pi here. And a pi is equal to 2 pi over 2 pi, or is equal to 3 pi over 3 pi, or is equal to 4 pi over 4 pi, or is equal to 6 pi over 6, because they are equivalent to 1. So that will help you think about calculation much faster if you're trying to think about those stuff. So here is 2 pi over 2, 3 pi over 3, 4 pi over 4, or 6 pi over 6. So this pi could be represents all those things. And I'm going to write down for you so that way you can see pi is equal to 2 pi over 2, equal to 3 pi over 3. That's equal to 4 pi over 4. That's equal to 6 pi over 6. That's going to help you as far as thinking about where the location is. Now, all I do is just count them. So you think about here is 8 pi over 2. Kind of makes sense. Here is going to be 2 pi over 2. Right? That's also 2 pi over 2. Right? So then you get to count them to here. That makes this one 3 pi over 2. And of course, this 2 pi also can be like 4 pi over 2, or it can be 6 pi over 3, or is equal to 8 pi over 4, or is equal to 12 pi over 12. So that 2 pi can represent in several different ways, so that keep your calculation. I'm going to help you again. This is pi over 2. Again, 2 pi over 2, 3 pi over 2, and then 4 pi over 2. So basically, you're adding each pi over 2 each time you go and count it clockwise for 90 degrees. Now, let's think about all the pi over 4s. All the pi over 4 is not exactly one location. It's basically break a circle into 8 parts, which is the blue part right here. And so here is 0 to pi over 2. Now, it's actually half. Basically, you cut half and cut half. Therefore, this one is actually pi over 4. So all of here is going to be pi over 4. Now count them. From here to here is pi over 4. From here to here is 2 pi over 4. Well, 2 pi over 4 is also known as pi over 2. When you get to here, it's going to be 3 pi over 4. Okay, 3 pi over 4. And then here is going to be, Gabby, can you let him in? I think it's my next period, but that's okay. Here is going to be pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4, like always says. So that makes counting of this part is really easy. This is going to be 7 pi over 4. 8 pi over 4. Oh, sorry, that's not 7 pi over 4, my bad. This one is 5 pi over 4. And 7 pi over 4. So I just do all the 4s. And all the 4 is exactly that half of a half, which is at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And you can count them. This is a 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So all of the spoke of this particular spoke of a wheel is all over 4. So that's kind of help you easier to think about all those like certain spoke is right between those two lines. This is all pi over 4. Now, lastly, you have to understand that this is actually this part here, the red part here is 30 degrees. Sometimes if you have 30 degrees, you can multiply it to get to the angles. So it's 180 degrees for pi radian. And that's how you convert. So that's going to be pi over 6. So I here it's going to be pi over 6. That means in this particular spoke of the wheel, it's always pi over 6. Now, the way to think about this is I'm going to go back to using that trick. The trick is this one is pi, also known 6 pi over 6. But if here is 30 degrees going this way, can I track it back 30 degrees this way? If I can track it back 30 degrees this way, that means I'm tracking back 6 pi over 6, but I'm subtracting pi over 6. So therefore, this one is going to be 5 pi over 6. And this one's going to be pi over 6. So you see, hopefully you see that relationship, because that relationship is going to help you a lot. And this is a red part of the triangle. Again, I'm going to say that again. This is a pi over 6 because going from here to here. Can I think about this as 6 pi over 6 and just subtract pi over 6 because I'm going backwards. So that's going to be 5 pi over 6. Well, that makes this one's pretty easy because instead of subtracting, you are adding. So therefore, instead of 5 pi over 4, 5 pi over 6, sorry, 5 pi over 6, 6 pi over 6, this one's going to be 7 pi over 6. So all the red part of the triangle is always pi over 6. And all this is a blue part. So we're going to show you this blue part. This triangle is really, really important for you to see though. So this is a blue part. You see that blue part is always pi over 4. And the red part is always pi over 6. And lastly, we're going to do is pi over 3. Well, I'm going to use black here. Actually, I might want to use a different color. Okay, let's do black. The black part here is pi over 3. So pi over 3 is around 60 degrees. So every time you move 60 degrees, exactly pi over 3. So if I move another 60 degree, that makes this one's 2 pi over 3. Again, this one's going to be 3 pi over 3. And then just keep on adding. This part is going to be 4 pi over 3. And 5 pi over 3. Of course, I forgot this part. Sorry, my fault. This one's going to be 11 pi over 6. The reason why is this is 12 pi over 6. I'm going back pi over 6. Now, with that being said, you're gonna see all those relationships correctly. Again, I'm gonna stress that there is a red part of it. All this part is a red part of it. And all this part is a red part of it. And they all pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Now, how do I know 5 pi over 6? Again, it's track it backwards. 6 pi over 6 going backward is 5 pi over 6. And this is 7 pi over 6. So it's very intuitive. And this 12 pi over 6 going this way and going this way. So now we just finished all the hardest part, which is the radian. The rest of the part is actually relatively easy. Now, I'm going to talk about what is unit circle. A unit circle means this is exactly 1 unit. So I'm going to show you what's 1 unit. Is the distance from here to here, the radius here is exactly 1. And it doesn't matter if that distance here is also 1. This is also 1. This is also 1. This is also 1. Because radius is 1. So each of those spoke of the wheel is exactly 1. Now, if it's exactly 1, that can help you define certain things. Now, this unit circle looks quite big, but actually, it's not quite big. If I go back to a Cartesian coordinates, so this is normal Cartesian coordinates. This circle just as big of this part. Just as big as that. But that makes this part is a coordinate. So this one is 1, 0. This is 0, 1. This is -1, 0. And this is 0, -1. So that makes this one 1, 0, 0. Oh, sorry, I'm gonna use black. I should better color orientation. 0, 1, -1, 0, and 0, -1. So knowing all your orientations, because this is a circle within the Cartesian coordinate, it looks really big, but it's just within those 4 squares. With that being said, now let's figure out what are those coordinates. Okay, so let's talk about SAT topic. The SAT topic has a geometry sections. So one of the SAT topic is on SAT, the first page, there was a page like this. First thing, there was a give you a reference sheet. And that reference sheet including certain things. Okay, that including this one is X, this one's X, this is a congruent to this one, and this is 45 degree and 45 degrees. And this is 90. So it's called 45, 45, 90 degrees. So if you got 45, 45, 90, then there was something, a ratio you have to remember. It's called, this one is going to be x square root 2. What does this mean? This means if I have this and this, and it's actually called isosceles, right? So you got 45, 45, and it's isosceles triangle. If this is an 8, if this is an 8, the automatic means this one's 8 square root 2. Because according to ratio, you don't need to do calculation. It's very, very straightforward. If this side is 8, this side 8 is called, it's not a base here. So this one is going to be the 8, this one's 8, this one's going to be 8 square root 2. Always going to be that way. However, this is on SAT, so pay attention, because Sometimes there's SAT question like this, and you gotta know how to manage with it. And geometry is so long ago, then it's probably hard. Now, what if this length is not giving? Let's say this is X, and this is Y, and this is 90 degree, and this is 45, 45. And if I say this side is 10, can you figure out what the X and Y is? So what you're gonna do is gonna set this 10 equivalent to X square root 2. So if you 10 equal to X square root 2, and if you solve for it, you divide it by square root 2 on both sides. And that's be X equal to 10 over square root 2. And if you rationalize it, that's going to be 10 square root 2 over 2. And that's equal to 5 square root 2. So it makes this one 5 square root 2. This one is 5 square root 2. And this one's on SAT. So you had to pay attention to, if they give you the hypotenuse is 10, you're going to set that 10 equal to X square root 2. And then you can evaluate those two lengths. If this side is 8, then just set X equal to 8. That means this one's going to be 8 square root 2. So that's very, very easy. Why do we talk about this? Because this is related to unit circle, and it's also related to SAT. Unless partial help you SAT score about 20 points, because a lot of time you're gonna have a 45, 45, 90 triangle, or we have 30, 60, 90 triangle. It's one of the big topic. Now, if you have 30, 60 degree, 90, that's called 30, 60, 90 special right triangle. So this is called special right triangle. And this is a special right triangle. Okay, special right triangle, special right triangle. Now, what happened is, this is actually a very, very important part is sometimes you have these situations. And this is not by scale by any means. So what if I have 30 degrees, 60 degrees, 90 degrees? How do I remember this ratio? Now remember, small angle face X, the smallest side. So we're gonna call this as X. The 90 degrees angle, which is the biggest angle in here, is gonna face 2X. So this side is 2X. And the 60 degree is gonna face somewhere in between. Well, what's between 1 and 2? Well, it's actually square root 3. So face X square root 3. So therefore, it's going to be X square root 3. With that being said, now, what if I have a right triangle like this? So we got 30 degree, 60 degree, 90 degree. And let's just say if I have this side is 5. What will be this will be, and what will be this will be? Well, if we know 30 degree is facing the 5, so 5 must equal to X. Now, the biggest angle is going to be 2X. 2X is equal to 10, so therefore the side is 10. Therefore, on this side is going to be 5 square root 3, because this says if this is 5, then this is going to be 5 square root 3. And that's how you evaluate something that help you along the way. Now, what happened if you get to here? If you have this 60 degree, this is 90 degree, and this is 30 degrees. Now, just say in this situation, I'll give you this side is 1. So in this case, you want to set 2x is equal to 1. Right? So x must be 1/2. So that makes this side must be 1/2. And this is 1/2 square root 3. And this is kind of important because we can talk about those a little bit more. And those are important values. So there are 2 types of situations can happen on a unit circle. In unit circle, we're going to talk about a blue triangle here, which is this part of blue triangle here. We have exactly a 45 degrees, 45 degrees, and 90 triangle. And we know this spoke right here, the one is thicker line, is going to be 1. So what we're going to do is we're going to go in and think about this. If this side is equal to 1, 1 equal to x times square root 2, therefore x is equal to 1 over square root 2 if we solve for it. If you change it, then it's equal to square root 2 over 2. So this part is square root 2 of 2 and square root 2 of 2. So that makes this is congruent to this, and that's going to be square root 2 over 2 and square root 2 over 2. So that makes square root 2 over 2, and that makes square root 2 over 2. So I always told students you need to understand what is going on instead of memorizing. Your teacher probably asks you to memorizing. I'm probably going to teach you to make sure you understand it. Let me repeat that again. Because this is a 45 degree triangle. According to ratio, this is x square root 2, this is x, and this is x. Now what happened is I'll set this part, x square root 2 is equal to 1, x equal to 1 over square root 2. If you rationalize, it's going to be square root 2 over 2. So that makes this one square root 2 over 2, and that's one square root 2 over 2. So what is this? This is the x value, which is this side, and this is this side. So those are, so this is square root 2 over 2, and this is square root 2 over 2. You just understand the length. If you understand the length, you don't need to memorize certain things. So that makes this square root 2 over 2 and this square root 2 over 2. Now let's talk about the other one. Again, we're going to talk about the red triangle here. If this side is 1, that means we need to figure out what this side is and what this side is. And that represents x or y. So you're going to set 1 equal to 2x. And then x is equal to 1/2. So that makes this part is 1/2. 1/2 is the y value. So the 1/2 is right here. And ratio, this one's x square root 3. So it'll be 1/2 times square root 3, therefore square root 3 over 2. So you can figure out that part. So I'm going to say that again. If this side is 1, facing 90 degree, and 1 usually equal to 2x, because 90 degrees facing 2x, x equal to 1/2. So this one is 1/2. 1/2 is the height of the triangle, is the y value of triangle, so it's 1/2 here. Therefore, that the other side here is going to be 1/2 times square root 3. So it's going to be square root 3 over 2. And yes, we are almost done with the unit circle. because the black triangle here, we're going to assume that this is a black triangle right here, or green triangle right here. The green triangle is going to give you exactly the opposite, because basically it's the same as a red triangle, but standing up. Now, if it's standing up, that makes they have a tall y value, higher y value. If the higher y value, that's going to make this one here square root 3 over 2, and this is 1/2. Now, rest of the information, just understanding this coordinate system. This is a positive, positive. This is negative, positive. This is negative, negative, and positive, negative. So you just have to fill in rest of the information because all the black triangle are alike. So this black triangle are alike. And that black triangle is reflecting. So therefore this is -1/2. And this is square root 3 over 2. This is -1/2 and negative square root 3 over 2. And this is a positive 1/2 and this is square root 3 over 2. So we just finished all the black part. Let's finish all the blue part. The blue part is going to be square root 2 over 2, negative square root 2 over 2. And here is going to be negative square root 2 over 2 and negative square root 2 over 2. And here is going to be positive square root 2 and negative square root 2 over 2. Let's finish your red part. The red part is going to be negative square root 3 over 2, 1/2. And negative square root 3 over 2, negative 1/2. And here is this positive 1/2 square root 3 over 2. So if you see all the red spoke, which is all the pi over 6, right? They all have exactly x and y coordinate. It's really depending on which quadrant is deciding your sign. And your sign is really determined by that. Now on your tomorrow, you have 7 minutes to finish this. Finish your unit circle. And you got to make sure you understand your unit circle very, very solidly. Okay. If you don't understand, then you're going to have problem later. And best way is understand the way I understand it. Now you're going to watch a lot of different TikTok or YouTube. But the problem is they don't teach you the understanding part. They don't teach you the SAT part. They don't teach you all the more important informations. Now, those are the things that you should see that it's matching. And you should see that this part is matching. All the red part is matching. And all the black part is matching here. Okay. So, and this is a unit circle. Hopefully you understand everything. Makes your life easier. The smart people only takes like 50 minutes to understand it, and they don't bother again. They just memorize it. I have students memorize it the first time they see it. They just understand it. So if you understand it, is it better off than you don't understand them? So best is always work on understanding. On the back side of the unit circle, there was something else. There was identities. So we're going to start a little bit about identity. And we might run out of time, but that's okay. So we're going to start with the reciprocal identity. You should see the reciprocal identity up there. And you should see sign of data, sign of data, cosine of data, and tangent data. Now that's the first you need to understand. Sine of data is 1 over cosecant data. Cosine data is 1 over secant data. and tangent data is equal to 1 over cotangent data. And the cosecant data is actually are reciprocal to each other, so it's going to be 1 over sine data. Secant data is going to be 1 over cosine data. And cotangent data is equal to 1 over tan data. Now, I always remember the SCCS, SCCS, CSSC. They are like kind of inverted to each other, but I just know sine and cosine is the one we know. So if we start with sine, should end up with cosecant, 1 over cosecant. And start with cosine, should end up with 1 over secant. So SCCS, that's kind of the small things I realized. There's one more, it's called quotient identity. The quotient identity is going to be, start with tangent. The tangent data is equal to sine over cosine. And the cotangent data is equal to cosine over sine. So that's the quotient identity. So those are the first two, and those are easy identities. Now, this is going to be used very often, so make sure you remember, use very, very often. The quotient identity is going to use very, very, very often. Now, I probably don't have time to cover all the identity, but this is a Pythagorean identity. Now, most of you guys know is the geometry Pythagorean identity. But we're going to use the geometry identity start with, which is a squared plus b squared equal to c squared. And we're going to use the idea called Sohcahtoa. Sohcahtoa. What does Sohcahtoa mean? That means sine of theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. So we're going to use that. So start with the Sohcahtoa. So a squared plus b squared equal to c squared. I'm going to take this, I'm going to divide it by c squared. And I know I can do that mathematically. So a over c squared plus b over c squared is equal to 1. Now let's talk about this. Just hypothetically, I have a triangle. And this triangle, we're going to call this one is the delta. This is the A, which is equal to opposite. And we got B is equal to adjacent. And C equal to hypotenuse. So if I have A over C also known as opposite over hypotenuse plus adjacent over hypotenuse, and those both square equal to 1. Now, since the opposite over hypotenuse is also known as the sine of theta, so it's going to be sine squared theta plus cosine squared theta is equal to 1. So that becomes the identity you need to know is sine squared theta plus cosine squared theta is equal to 1. That's called Pythagorean identity. In trigonometry. In trig. There was 2 other one. And using those 2 ideas from here, then you can get 2 other one. So this is the first one I will say you need to memorize. You don't have to get this part. This part is not needed on the quiz. I won't quiz that part. I'll just quiz the unit circle tomorrow. And then I don't take a quiz on the thing, on this part. So when we take this unit circle, I'm going to divide it by cosine square. So I'm taking the first one, divide everything by cosine square theta is equal to 1 over cosine square theta. So we know that if I take this and divide it by sine square, or divided by cosine square. So if I take it divided by cosine square, I'm going to get this new function, but we can simplify by looking at the quotient identity. So sine over cosine, that's equal to tangent. So that becomes tangent square theta plus 1. 1 over cosine is right here, is secant. So that's equal to secant squared theta. And second part is going to be take the same thing, I'll divide it. So will be take the same thing, sine squared theta. So this becomes the second equation. Sorry, that's becomes second equation. The third equation is going to be taking the sine squared theta plus cosine squared theta equal to 1. I'm going to divide it by sine. If I divide it by everything by sine, then that's equal to 1 plus cotangent squared theta is equal to CSC squared theta. And that's all you need to know for today. And the unit circle, you have to know by tomorrow. This part, I'll give you an extra day. And that should be all. And you can bring more sheet of unit circle if you want. Because I print out extra. So not the other side though, only in the unit circle.
Mr. Ye. Mr. Ye.
Yes.
For 330 degrees on the number line, I think the coordinates are switched.
Did I? Which one?
330. The
Oh,
red
yep.
one.
You are absolutely right. Thank you so much. Can you let the student know?
Yes.
Thank you. I didn't make a mistake. Okay, so you guys have to let everybody know they have to have a unit circle done by tomorrow. And you have 7 minutes to do it.
Okay, are we only doing the coordinates, radians, and degrees?
Yep. And that's it. You don't need to
So-
worry about the positive, negative. These are not important. And
Okay.
this is going to be the next quiz. And the next quiz is going to be the identity, but I cannot finish all in one day.
Okay. Thank you.
Okay. It's on the other side. You guys can grab as many sheets as unit circle as possible. So if you need 3 sheets, grab 3 sheets. If you need 4 sheets, grab 4 sheets.
Okay, thank you.
Okay.